My good students, let me again thank you for finding time to be with me for this lesson under sequences and series. But under this one, I'm going to be majoring on geometric sequences. Want to know what are these geometric sequences and also how to solve questions related to this area of geometric sequences. Now, on a quick note, realize that a geometric sequence is a sequence in which the consecutive terms have a common ratio. And remember, this common ratio, you can obtain it by taking the, the second term by the first term or the third term by the second term and so on and so on. Now, terms in geometric sequences are as follows. You're going to realize the terms are arranged as follows. That is, A stands for the first term. To get the second term, you multiply by R. To get the third term, you multiply the second term by R, and so on until the last term, which is given by A, multiplied by the common ratio raised to n minus 1. The last term of any given geometric sequence is actually given by a r raised to n minus 1. So if you know the number of terms, then you can actually get that particular term that you are interested at. Now, for example, given the geometric sequence that is 8, 4, 2, a half, up to the last term being 1 over 5 over 1 over 512, then the question says find the number of terms in the above sequence. So realize that you are given the last term here, and therefore we can easily determine the number of terms in that particular sequence. So how do we proceed? This is how we are going to proceed. One, realize that the first term is 8. The first term is 8. The common ratio is 4 over 8, which is the same as a half. That is, you take 4 divided by 8 or 2 divided by 4. That means the second term by the first term or the third term by the second term and so on and so on. So by so doing, we realize therefore that our common ratio is a half, which implies therefore, remember that the last term, that is nth term, is given by AR raised to n minus 1. And if you substitute this one, the last term is 1 over 5 over 12. 1 over 512 equals to 8, which is the first term, and then multiplied by r, which is a half, raised to n minus 1. So we can simplify this expression by dividing by 8 across. We want to divide by this 8 across to remain with a half raised to n minus 1 equals to, once you divide with 8 here and you write it as you raise it as its prime factors, then you're going to find it's going to be a half raised to 12. You express it as an index form, so you're going to have it as a half raised to 12. Now realize that the bases are the same. This is a half and a half, and whenever in index form the bases are the same, then you equate the powers. So we are going therefore to say n minus 1 equals to 12. And by so doing here, we can simplify and get it as n equals to 13 for that case. Now, there are other aspects under this one which we call the geometric progression, and this geometric progression is what we want to see what it is and how to go about it. And realize this one, that the sum of the sequences of numbers is called a series. So if you sum individual terms in a sequence, then you get what we call a series. A series with specific number of terms, we refer to it as finite. So if you know a series with specific number of terms like 5, 10, 20, then such a series we refer to it as finite series. But that series that has continues indefinitely is said to be infinite. That means it has infinite number of terms. Then we refer to that series as infinite series. Now, a series in which the next term is obtained from the previous 1 by multiplying using a fixed value is called a geometric progression, which sometimes we refer to it as a GP. This fixed value that we multiply the previous term to get the next term, we refer to it as a common ratio. And that's why you can see here, like this is the term. To get the next one, we multiply by a fixed term, which is the common ratio, and so on and so on. So from there, therefore, we can note that the sum of any n terms of a GP is usually given by the formula. That is, that if you have n terms of geometric series, then to get the sum, we write it as Sn, where n is the number of terms, equals to the first term into bracket 1 minus r raised to n. Remember, we've said A is the first term, R is the common ratio, N is the number of terms that we want to find the sum of such terms, and so on. Now, this formula or this one will just give you the same results, where you ensure that R should not be 1, because if R becomes 1, then you're going to have the denominator being 0, and therefore it's going to cause this relation to be indefinite or undetermined or undefined for that case, because you're going to be dividing by a 0. So ensure that whenever we are dealing with this one, R should not be equals to 1. Now there is an example here that I want us to check. They're saying that find the number of terms, or find the sum of the first 5 terms of the following series. That is 9 plus 27 plus 81. It says find the sum of the first 5 terms of the series. We are starting with 9 plus 27 plus 81. How do I proceed? The first thing I'm going to do is to write down what I'm provided with. Realize that the series, first of all, is a GP, and therefore A is 9 and R is 3. How am I getting 3? I'm taking 27 divided by 9, or 81 divided by 27. That common fixed term that you are getting, or common ratio, is therefore 3. Once I have those, then I can recall the formula where I know I'm getting the 5 first term. I'll say S equals to S5 equals to AR, A into 1 minus Rn, over 1 minus r, which implies I can actually substitute this one quickly. A is 5, 1 minus 3, because r is 3, raised to n, which is 5, over 1 minus 3. So if you work out this value here, we end up with 1089. Second example, the third term and the sixth term of a GP are -3 and 24 respectively. Find A, the common ratio. Find the common ratio. And on a quick note, we are going to check the solution of this. And how do I go on? First of all, I look at what I'm given. Remember here, we are given the third term, which is -3, and the sixth term, which is 24. So I recall that the third term is AR squared, which means that equals to -3. I'll call that one equation 1. Once I have that, then I also recall that the sixth term is AR power 5, which I'll equate it to 24. I'll call it again equation 2. Once I have the two equations, then I'll try to divide. In other words, I'm trying to solve them. And the easiest way of solving this one is to divide the two equations so that some of this unknown value can cancel out. So I'll divide equation 2 by equation 1. That will be AR raised to 5 over AR raised to 2 equals to 24 over -3. So realize A will cancel, and 2r will cancel to remain with r cubed. So I'll say r cubed equals to -8. And to get r, I'll take the cube root of both sides. And remember, the cube root of -8 is -2. Therefore, I'm getting r as -2, telling you that that is a decreasing series because of this negative. That's why you can see the third the third and the sixth term are this one. Note that we are getting r to be negative 2 for that case. Now, the next question is asking about the first term of the series. Remember, the first term of the series can be obtained if we know the third term and the common ratio. You are told that the third term is negative 3, and the common ratio we have obtained it as r equals to negative 2. And therefore, what you're going to do here, we are going to substitute in for r in equation 1. Look at that equation 1 here. We have the value of r and we're interested with a, the first term. So substituting the value of r here, we are going to have ar squared equals to negative 3, implying that a into negative 2 squared. Remember, r is negative 2. U squared is equals to negative 3 is equals to negative 3. Now, simplifying this, you get that 4a equals to negative 3, implying that a equals to negative 3 over 4. A equals to negative 3 over 4. Once we have that, then we can now proceed on with other more questions that are related to this problem. That if you know that the sum of any particular geometric series is given by this relation, then you can actually use this relation to a number of questions under this area. So follow me, of course, for the next video, which will be on arithmetic progression. Thank you for your time, and also you can subscribe for more and more lesson on the same. Thank you, and have a good time.